So one of the entry points that you and I have talked about over the last couple of weeks, and you've been working on, is re-architecting software to following the spirit of 62304. So why is it important to have like a methodology for doing this, for re-architecting software?
Yeah, I think the biggest thing is just building in that initial quality. Software is unique, and as I'd mentioned before, that you can kind of start making changes, a little bit more rapidly than you can in some of the other, mechanical or electrical design processes. We can rapidly change software, and that kind of leads to maybe changes that aren't completely thought through, or things that we're doing kind of in a pinch in the short term until we can get, updated mechanical hardware or electrical boards or things like that. So it's important to follow a process when implementing changes on the software side. I don't think you want to get yourself into a position where you've kind of rapidly added a new software module to deal with a certain hardware quirk or something like that that will be eliminated in the next revision. So you want to make sure that you're following kind of a proper process and that you don't end up with code that hasn't been kind of through the same rigor that you'd want it to get through.
I'm all about process for sure, and I know our clients are, but I guess just we talked a little bit about time before. So to me, it sounds like following 62304, or the spirit of it, is arguably slower than just going in there and fixing it. So, because you're taking more time, you're applying this methodology. Um, does it save you time in the long run?
Yeah, absolutely. I think going back to, what I mentioned, I think when you develop without these processes in place and you're not setting up your requirements, you're not thinking through an architecture that can support the growth of the system. In the short term, maybe you save a little bit of time. Maybe you're able to, get a release out sooner or get to a prototype a little bit sooner. But I think in the long run, you're definitely losing time because, to make the bigger changes that you most likely need to do to go from kind of an early prototype, you may not have the requirements, you may not have thought through kind of all those processes. So really, it's kind of saving time in the long run and saving that time from the first step to the next step. When you're going from your early prototype or your demo device to your clinical trial or to your on market device.
What are some examples of customers struggling by not applying this sort of methodology?
Sure. I think the one that comes to mind first is that you end up with a code base that doesn't have that pedigree or that the documentation that's required to make the changes that you need to. Oftentimes you'll have one set of developers working on the early prototype, and then either a different set or an external contractor come in, and it's difficult to pick up where someone else has left off, especially if you don't have the design process, elements in place. If you go through and the requirements don't trace to an architecture, or the architecture doesn't trace to what's actually implemented in the code, you can end up losing time trying to understand where the delta is there, as well as why was something done in code this way, versus in the initial documentation it was specified a different way. So that's what I've seen probably in the real world most often. It's just trying to understand and kind of work through those discrepancies.
So I guess talk a little bit more about how you go about understanding what's been developed, just kind of lay the groundwork for implementing 62304.
So the first thing that we typically do when approaching either a kind of a new code base or new system is look at the documentation and talk to the developers that were involved with that process. Talk to them about 62304. What processes they may have followed. Did they follow 62304? What documentation was generated, and then start putting together the picture, of this particular device. Starting with the safety classification of the software. Did the process elements that they follow match the safety criticality of the device being developed? Then, kind of checking that the requirements and architecture definition, as well as looking at the code and making sure that actually follows what was done in the initial planning phases of the project.
So, the next step you mentioned is kind of defining the architecture. What do you mean by that? And specifically, like defining the architecture by following the spirit of 62304, but not actually following the standard.
you know, Following at this phase of the development process, the spirit is very similar to the actual standard itself. The architecture you're defining. When we talk about architecture, we're talking about, okay, are you going to have an embedded system that controls motors, pumps, things like that, and do you need a PC software that kind of deals with the high level the high level tasks, dealing with the user, planning, movements for a device or something like that. So when we say architecture, that's really what we're defining. What needs to live on the firmware side, what is real time, has timing constraints, things like that, and what requires more storage and memory, that would fit better on a PC side. So really, that's what we're defining. And if that is not done carefully, you could easily end up in a position where, maybe you're trying to do everything in firmware, and then you find out that all of a sudden you need to collect a large amount of raw data or something like this for a diagnostic device, and you just don't have the storage space to store it. So it's very critical early on to try to identify where those interfaces are, what each portion of the software is going to do, and why it needs to do that, and then also thinking through the for the future. If you weren't developing to the spirit of 62304, you may just decide, okay, I'm going to just jump right in. I know what this device needs to do. I understand the firmware. We have our software requirements. Let's go ahead and just start implementing. And that's where I think you kind of run into trouble, where you've developed yourself into a little bit of a corner where you can't with this the microcontrollers and the software architecture you defined actually accomplish the goals of the device. So by following the spirit, you'll go through that architecture phase, think through it, trace it to your requirements, and then you in theory are setting yourself up for a more smooth development in the future.